Hello everyone, welcome back to our channel. Today we are going to discuss about few applications of acceleration due to gravity. In previous section you know that time of ascent equals to time of descent equals to u by g. Time of flight is the total time taken by the body in air, that is the 2u by g, and maximum height h equals to u square by 2g. Few applications we are going to discuss now. Look here, we are taking one body that is projected vertically upwards. It reached to the point P. This is one tower we are taking. This height is h. This height is h. This point P it is covering two times. First time it is covering at t1 seconds. Later it is while coming down it is covering at t2 seconds. So when the body is projected upward, suppose I am standing here, while going up it is covering this point, while coming down also once again it reaches to that point. In this case, how to find out the maximum height and how to find out the projected velocity and what is the height of that P, everything we discussed. But the given data is at point P it is going two times, while going up it takes t1 seconds, while coming down it takes t2 seconds. So from the given figure, clearly we can observe that time of flight from ground to point P, first time t1 seconds, from here to here this is the t2 seconds. So from here to here total time is t1, means remaining part is nothing but t1 seconds. So time of flight equals to t1 plus t2. But time of flight formula is 2u by g equals to t1 plus t2. From this, initial velocity or projecting velocity of this one is u, and a equals to minus g because this is projected vertically upwards. Here u equals to g by 2 into t1 plus t2. t1 plus t2. One application, you know that one formula. Then next thing is, what is the height from ground to P? Suppose you are taking, this is the small h, and total height of this tower we are taking capital H, nothing but maximum height. We can use second equation of motion, h equals to ut minus half gt square formula. Ut minus half gt square formula. Here h equals to, you know that u value is g by 2 into t1 plus t2. It reached to the first time means this is t1 seconds into t1 minus half into g into t1 square. After simplification, h equals to, this is first one is the half g t1 square plus half g t1 t2 minus half g t1 square. This one cancel, h equals to half g t1 t2. So don't think this is the maximum height. This is the height from the ground to this point P. The next thing is maximum height. In this case, how to find out the maximum height? You know that in the case of vertically projected body, maximum height formula is h equals to u square by 2g. Instead of u we are writing u square. So g square into t1 plus t2 whole square. This is one more 2 is there, 4 into this 2g. Finally h equals to, we are getting 1 by 8 into g into t1 plus t2 whole square. The question is, when the body is projecting upwards, it covers at point P, first time at t1 seconds, while coming down it takes t2 seconds. What is the projected velocity means u equals to half g t1 plus t2. What is the height of that point P from the ground is half g t1 t2. Then last one is maximum height equals to 1 by 8 into g into t1 plus t2 whole square. We do one problem based on this. If t1 equals to 2 seconds, t2 equals to 4 seconds. Here how to find out this one. Now no need of doing everything. We should remember that formulas. Here what is the formula for projecting? U equals to half into G into T1 plus T2. G value we are taking 10. T1 plus T2 is the 6. 2 3. This is how much? 30 meters per second. Then what is the height of that P from the ground is H equals to half into 10 into T1 T2 is the 8. This is 40 meters. Then capital H equals to 1 by 8 into 10 into T1 plus T2 whole square. T1 plus T2 is the 6. 6 whole square is the 36. So H equals to 45 meters. So these are the formulas. One more application. If one stone is there dropped into the well and we are looking like that. Even we are not looking also. We are listening one sound. A splash of sound after some time. So how to derive this equation? How much time it will take to listen that sound? So for that, this is the well we are taking. This depth of this one is D. We are dropping one stone. It touches this water. It takes T1 seconds. So you know that for freely falling body, initial velocity equals to 0. Then we can use here H equals to half GT square formula. Instead of H, depth of this one is D. Then half into G into T1 square. From this T1 equals to under root. If we want to continue H only, we can continue the H. So how much time to reach that water is 2H by under root 2H by G. At that time we are not listening the sound. When it strikes the water, then that sound is coming, that is reflecting and coming towards us. At that, how much time it is taking? While coming up, we are taking T2 seconds. T2 how to calculate? General formula. Depth of or height of this well, distance by velocity of sound, we are taking Vs. So total time to listen that splash of sound is T1 plus T2. It should be right under root 2H by G plus H by velocity of sound. We are doing one question here. If H equals to 19.6 meters, then velocity of sound we are taking 330 meters per second. Then how to find out? Sometimes they won't give, sometimes they will mention 330 to 340 meters per second. Based on that, we should do this simplification. So in this case, how much time it will take? Under root 2 into 19.6 meters by G. G value 9.8. This is 2 plus height of this one is 19.6 by 330. So after simplification, we can find out the time of this one. So we can find out the T1, we can find out the T2, and total time also we can find out, because velocity of sound is the standard one. One more application we are going to discuss here. This one mostly we are using. The concept is, here one tower is there. Height of the tower is H. Height of the tower is H. And the body is projected upwards from the top of the tower. So the body is going upwards. It reached to the maximum height. Because of the gravitational force, it is coming down. While going, suppose the distance is x. While coming, the distance till here is minus x. Anyway, total displacement is how much? Nothing but height of the tower. But the thing is, here we should consider height of the tower, we are taking negative side. Why? Initial point is above the final point. So displacement we are taking S equals to minus G. And that too, this is projected vertically upwards. So A equals to minus G. Then how much time it will take to reach the ground means, we can use simple formula S equals to ut plus half at square. But instead of S, we are taking minus H. And this is the ut plus, but it is project. Most of the people we are confusing, instead of A we are taking G. We are thinking in our mind it is coming down. Whatever the body, it is coming down only. But initially if we are projecting upwards means A equals to minus G. So minus half GT square. After simplification it should be right, minus we should cancel. So H equals to half GT square minus UT. Then we take the LCM and we do the simplifications with the help of the quadratic equation. GT square minus 2UT minus 2H equals to 0. Then we can use T equals to minus B plus or minus B square minus 4AC by 2A formula, and we can derive the expression for T. So T equals to, here B equals to minus 2. This is like AX square minus BX plus C. Here B equals to minus 2U, minus into minus plus 2U plus or minus under root B square is the 4U square. Then minus 4AC. Here A is the G and C is minus 2H means plus 8GH divided by 2 into, here A is how much? G. After simplification T equals to U by G plus or minus, here 2 cancel and we are taking 4 is the common means U square plus 2GH by G. So this is the time taking to reach the ground when the body is projected vertically upwards from the top of the tower. Same case we are using in the case of helicopter and aeroplane. If we are dropping one body means in our mind we are thinking that velocity is 0. But whenever the stone is dropped from the aeroplane, it is coming with the velocity. Initial velocity is nothing but velocity of that aeroplane. Here we are projecting upwards means projected velocity means it is having some velocity. So in the case of parachute also, we are dropping one body means it is coming downwards with the same velocity of that parachute. So with the help of this we can find out the height also, we can able to find with the help of this, and we can find out the how much time it will take to reach the ground. We do one problem also. If U equals to 2 meters per second, then T equals to 8 seconds, then G value we are taking approximately 10 meter per second square. How to find out the height of this one? So we can go through the H equals to U half GT square minus UT, half GT square minus UT. So 1 by 2 into 10 into, here this is 64 minus velocity into T 60. So H equals to 320 minus 16. So like that we have to do the simplifications. We can find out the height. Thank you.